Hey, physics Padawans, it is the Master coming to you, hopefully for the last time. Quiz number two. I want to talk to you about what I saw, what I keep seeing, and things that I'll just put a different spin on some things to hopefully guide you through this last time through this quiz. So I went through all the grades and just to kind of show you, these are the number of people of the 83 of you that took it. 48 of you, 5/8 of you, that's 0.625 in case 62.5 of you did better. Uh, what is that? 40, 70, 7/8 of you stayed the same or did better. 13 of you are on drugs, or maybe you need to be off the drugs. I don't know. Something funny is happening here. What it is isn't exactly clear. You got worse, and I don't know why that is. Maybe you could kind of look at it if that's one of you, but I'm super proud of you. And a special shout out to Tate. Tate is the player of the day, most improved. If you see Tate, please pat Tate on the back for me. Let's get to it. Um, Part of me thinks I'm being too nice. I'm putting these in order, like a case one, case two, case three, case four. I'm like putting them in order for you. I really should be jumbling these things up so you don't get them so nicely. So case one, I'm going from not a prefix to a prefix. You're getting better with your numbers of your prefixes, but what I'm still seeing, N to P, pico N. N is newtons. Newtons are a unit of force. Pico is a really tiny thing. So that means that the one goes down there, and pico means 10 to the 12th. I'm still seeing people putting positive x or negative exponents in there. That's a no-no. It's a no-no unless you are a smart fart. Let me show you how to do this problem with negative exponents. And then we'll still do the Newton on here, and we'll do the pico-Newton there. But instead of putting a 1 at the larger, you put a 1 at the smaller. And now pico, one Newton, it's a very, very small piece of a Newton is equal to a pico-Newton. So I put 10 to the negative 12. Now, those of you who know your properties of exponents, if you've got a negative exponent in the denominator, it pushes that 10 to the 12th in the numerator. So that's why these are the same. But what you can't do is you can't put a negative 12 here and expect it to be the same as these two things. You're going to get it wrong. So when you put a 1 on the larger thing, you're always going to use positive exponents. Number two, people are still biting off more than they can chew. This is a prefix to a prefix. It's case 2, and you're going to take an intermediate stop at the base unit. So you're going to start out here with 6 million kilotons. We'll go from kilotons to tons, and then I'll go from tons to where I'm trying to get to, gigatons. I do all of my fractions first before I put my numbers in here. I don't know if you noticed that when I'm doing this, but this is a tactic that will help kind of keep you organized. So kilo is the big thing, and kilo means 1,000, 10 to the 3 power. Giga is the big thing, and giga means 10 to the 9th. This is why, now again, properties of exponents, 9 minus 6, I'm sorry, 9 minus 3 is 6. This is why another way to do this is that 6 kilotons. Some of you can do this. Some of you can go from kilotons to gigatons. Not all of you. Know who you are and know how confident you are in this. And that is why giga is big, but it's 10 to the 6th. There are a million of these in that. Even though kilo means that to the 3rd, and this means to the 9th, 9 minus 3 is 6. So if you're not comfortable, don't do it. It's so much better to get it right and take an extra step than to get it wrong and try to go fast. I was one of these kids in high school. I totally get it, but I got enough of them wrong that I was Not going to graduate or pass some of my classes in college, so I bit the bullet and now I'm neater and I'm slower and I take my time. That will be you one day. Fractions. People are not writing their fractions. 75 milliliters. Write it in this type of fraction with the horizontal line and put minutes on the bottom. That way, when I change from minutes to seconds, again, see, I'm not putting any numbers in. I'm just doing, so now I'm going to put, I have milliliters on the top, so I have to put milliliters on the bottom, and I'll go to liters like that. So I'll fill in my units, put a 1 by the minutes are big. There are 60 seconds in a minute. Liters are big, and there are 1,000. They don't have to be alternating. I get a lot of people, some people are getting confused that you think that you have to have alternating numbers. Nope, the big numbers can be all on the bottom, the big numbers can be all on the top. It all depends on how I engineer the problem to try to fool you. Next problem, to our foreign exchange students. Would you believe that these are the only countries, the United States, Liberia, and Myanmar, who use the imperial system? Our friends in the United Kingdom, they will mix it. They'll refer to like their volumes and like liters, but they'll refer to their distances. If the distances are, I think within a like if it's short, they'll say, oh, that's 5 feet long. I'm 6 feet tall. But if it's far, they'll say, oh, it's 10 kilometers away. So that's why this is mixed. Well, lo siento to our foreign exchange students who have to, but this is your introduction to feet and inches. So in the problem, I told you that when you go inches to feet, that in 1 foot there are 12 inches. Now, because they're cubed, we have to also cube this. There are like 12 times 12 times 12, well, whatever, 144 times 12 cubic inches in a foot. So there, that one right there. Lastly, this one was a gem, this last problem. It's a combination. It's like a fraction and a prefix to a prefix and exponents. So it is like to the max. This is supposed to be a 2. So there's a couple ways to do this. I'm going to show you 2 ways, but maybe you did it something else. Maybe your brain works in a different way that Mr. Hare's doesn't, and that would be a good thing a lot of times. So 15.8, sorry about that extra 1 point there. mg, I'm going to write my fraction correctly over millimeters squared. First thing I'm going to do is I'm going to go from mg to g. So G is the big thing, and I'll put milli as 1,000. Here's the tricky one. I want to go millimeters squared to centimeters squared. I actually know this. Mr. Hare's brain works this way because I know how many millimeters there are in 1 centimeter. Can you guess? You're right. There are 10. There are 10 millimeters in 1 centimeter. But since this is squared, I got to put a squared there, and I got it. So this licked. The other way to do that, if you don't know how many millimeters there are in a centimeter, you'd still start it out the same way. Where you're going to differ, you're going to go from millimeters squared, because see how it's on the bottom and you got to make it on the top. People are screwing them up because they're writing it in weird fractional form. Write it so it's on the bottom so you know it's on the top. I'm going to go to the base unit, and then I'm going to go from my base unit, and I'm going to go to where I'm trying to get to, which is centimeters squared. So filling in my fractions, putting my numbers in. Meters is the big thing, and I know that there's 1,000. There's 1,000 millimeters in 1 meter, but since this is all squared, I have to also square this again, which is 10 to the 6th. Right there, if you're going to get rid of that something, 10 to the 6th. There's a million of these in that. Over here, 1 meter. There are 100, 10 to the 2 power, centimeters in a meter, but then I have to square that again. Or this is 10 to the 4th. I could do a little bit of math canceling so that like 6 of these minus 4 of those, 6 minus 4 is 2. Haha! There it is. These are, with my flexible equal sign, equal to each other. All right, friends, you did well. We're going to move on to sig figs today, and I'm going to give you another quiz at the end of class. Believe it or not, there's going to be a couple of these on there. Not as many, just 2, 3. but good luck, and we'll see you Friday.